Alright, boys and girls, it's time to get a little regular. Essential question. How do you find the area of a regular polygon? Well, let's recap what a regular polygon is. You see the definition from before. A regular polygon is a polygon that is equilateral and also equiangular. So all the sides are exactly the same and all the angles are exactly the same. Now I just drew a simple little hexagon here, a regular hexagon, and quite honestly in this section throughout, hexagons are one of the ones that you're going to see a lot when we're doing with area and other things. But regardless, a couple definitions that you need to know. In any regular polygon, not just a hexagon, there's something in the middle here. That point is very similar to like the center of a circle. It is called the center, that point right there, it's in the middle, of a regular polygon. Now with that, here comes two definitions. From the center, if you draw a segment to the vertex, or over to this vertex, or to this one, it doesn't matter. That definition is actually called a radius, or that word. It's called a radius. That thing is a radius of the regular polygon. And you see the definition, it's a segment joining the center to any vertex. So that said, there's a couple things that's important also about radius, other than looking in your book, but here's the two that I'm going to point out to you. This thing, the radius, bisects the angle of the regular polygon. So this radius bisects that big angle into two equal angles right there, as it would over here if you drew it. It bisects into two angles, both of those are equal. It also is something that's important too, which should make sense, but we're talking about a regular polygon. All of the radii that you would draw in the regular polygon are congruent. Okay? Another definition. From the center, if you draw a line straight down or over here or over there, that goes to the midpoint of the side. So the actual midpoint goes right there. That has a special name called this. And just so you know, this is how you pronounce it. This is kind of gross, but this is how you do it. There's those goofy little animals that most times your parents like, you know, when they're driving in the car, you hit them sometimes. They're small little rodents about this big. You only see them at night. They are white. They hang upside down in trees. Well, think about what that is, and you can say it out loud. Got it? What you need to do, though, is this. Stick out your tongue and grab it. Okay. And then you need to say that word of that animal. So it's a possum, but if you go like this, opossum, that's how you pronounce it. It's an opossum. So an opossum is by definition a segment joining the center to the midpoint of any side. A couple things that's majorly important about an opossum is this. The first one is megally important. Perpendicular bisector. It is a perpendicular bisector to any side that it's drawn to. So not only does it do this, it does this. That is extremely important. And all the opossums in a regular polygon are congruent. Not just this hexagon, any regular polygon, it will work. So the question, though, remember, is still this. Area. How in the world do we find the area of a regular polygon? Well, here's your definition. Well, that's not right. It's a theorem. Here's your theorem that you use. It's Theorem 107. Theorem 107 says the area of a regular polygon is 1/2 A times P. Now, I know we have AP courses in this school. That's not what it's talking about. A is the length of the opossum, whether that's given to you or you have to find it. And P stands for perimeter of the regular polygon. Now, that's nice because a regular polygon, remember, is equilateral. So as soon as you find one side length, you can know the perimeter pretty simply. So you got to find the length of the opossum and the perimeter length. So if you have a triangle like this, that's the opossum. You have to find that. And you have to find, I don't know, one side of this triangle, whatever it be this, maybe it's that whole thing, whatever. You just plug it in, take and multiply it that 1/2 times the opossum times perimeter, you'll get your answer. Here's a square, that's a regular polygon as well. So there's your opossum. You could find the side length somehow, that would be pretty simple. And here's a square. There's your opossum in a square. I'm gonna pause you. I wonder if you caught it. Opossums are not in, did I say square? I meant circle, sorry. Opossums are not in circles. Why? That looks like it. That's pretty cool. Well, first of all, here's what you can realize. This is a curved particular, it's not even a segment, it's a curved thing. So there's no way that that can come down and be perpendicular to it. Plus, by definition, if you look back, a circle is not a polygon. But I want to draw it in there just to see if it trick you. But you could do this. You could draw a tangent as such, and that tangent and the radius is perpendicular, it's still not called an apothem because apothems only occur in regular polygons. That's why I wanted to show you that example. So let's do an actual example of finding the area of a couple things. Now, example 1, find the area of an equilateral triangle with an apothem length of 6. So here's your equilateral triangle, the apothem length is 6. My formula, I know the apothem length already, so that's why I put 6 in there. The trick is just finding what the perimeter actually is. So to find the perimeter, well, let's kind of scooch over here to the right, but before I do that, let's do this. Let's draw this guy right there. That's a radius, so I'll just make it up, whatever. So there's your radius. Why is that important? Because remember, in an equilateral triangle, all the angles are 60. But we just learned that the radius bisects the angle, so that angle right there has to be 30 degrees. So if I pull over to the right, that's 30. This has to be 90, so we're looking at a 30, 60, 90 triangle. Oh, there we go, 30, 60, 90. So x is across from the 30. There you go. Across by 60 degree angle down here would be the 6 root 3, or the x root 3, which 6 is x. And then across from the 90, not that it matters so much, but this would be 12. Doesn't matter at all, because all we needed to find was the perimeter. So now we found this to be 6 root 3, but be careful, 6 root 3 doesn't go in here. 6 root 3 is only this distance from here to there. So that means the whole side length is actually 12 root 3, which means the perimeter is 3 times 12 root 3, which is 36 root 3. So 36 root 3. Phenomenal. So when you multiply that out, that would give you an area of 108 root 3 units squared. So there is your answer to that one. All right, let's go to example number 2. Find the area of a square with a radius of 8 root 2. Well, here's your square, there's your radius. Now here's what I can look at. If I look at this radius, I know it bisects the angle. That's what a radius does. Boy, that's cool. I know all the angles of a square are 90, so if I bisect that, that's 45. Ooh. Now if I drop an apothem right there, making a right angle, that means I'm looking at a triangle. That's 45, 45, 90. Sweet. So I'll pull that triangle over here. So this is 45, 45, 90. And my 45, 45, 90 triangle theory, remember, x and x root 2 is what the side lengths are. So that means across my 90 is what x root 2 is. So if I'm going to do the math on that, x root 2 equals 8 root 2. Check this out. Divide both sides by root 2. The root 2's cancel. That's pretty cool. Which means x is 8. So that's awesome because that means the side length here is 8. Time out. That means this piece from here to here is 8. Which means the whole side length has to be 16. So there you go. So 16, I put that in here. 16 squared would be, last time I checked, 256 units squared. So there is your answer for the area of that particular square. Cool. Now the next example, I'm going to again set it up for you, get it all ready, and then you're going to do it on your own. I'll pause the video, and then I'll make another video after this to explain how to do it. So the question is, here's your regular hexagon, and it says the radius is 22. So it's already drawn in there. It's a regular hexagon. 3 parts to this question. Find the length of the one side. So you got to find the length of one of the sides. Doesn't matter what it is. And then find the length of the apothem. And then find the actual area. So there you go. Good luck. I will give you a video next, and I'll go through all this, and we'll see how you do. Good luck. I believe you can get it. Wink, wink. You got it.